For our next story, we're taking a bit of a left turn, although we're staying in Tech Central, as we explore some recent research into augmented reality. Now, augmented reality is where computer-generated images, or data, are added to real-time images. Hence, reality is augmented, or improved. Now, to create augmented reality, you need a camera and a display. Well, I've got both of those on my phone here. Yes. And the trouble is the system still needs to know what it's looking at. And that is the really clever part.
Our research has let us look through walls, fold buildings, or even demolish them. Before you learn how it works, it can seem a bit like magic. So that's why we call it the Magic Vision Lab. Hi, I'm Chris, and we are creating cool new technology, and today we're going to reveal the tricks of our trade. My team works on augmented reality to bring the real and virtual worlds together. First, let's look at some techniques that use tools most of us already have, smartphones. We are researching ways to use them as a display to give the user more information about a particular place. To do this, we need to know exactly where they are and generate realistic images in real time. We can start with the phone's or tablet's GPS signal, which is accurate to about 10 meters. But we really need a much more precise location. To fine-tune it to a few millimeters, we are experimenting with a system called vision-based natural feature tracking. This type of software can use any object as a landmark, kind of like a reference point. Using the built-in camera, it recognizes landmarks and figures out their distance and direction. So we know where the display is. The next step is to generate realistic graphics to be added to the scene. To make our images look real, we use an approach called ray marching. This models how light would interact with the virtual objects to reflect, refract, and cause shadows, so they will look more like they would in the real world. But this is a bit too complicated to actually perform on the smartphone itself, so we are working on ways to process the graphics online and stream them directly to the smartphone. Within the next few years, our tools will be very important for archaeologists, tourists, field researchers, basically anybody who needs to know more about the environment.
Yep, that is some pretty cool stuff. I can't wait to be able to access it myself. Oh, and stick around because we're going to be heading back to the Magic Vision Lab very shortly to check out a virtual floating fish. Stay tuned. Hello and welcome back to Scope, and a Scope episode that is quite high-tech because it's all about technology. But, well, what does that mean? Well, what better way to explain than by giving an example? And in this case, we're heading back to the Magic Vision Lab, where they're combining haptics with computer-generated sea creatures. I think I'll let Christian explain more.
Thanks, Dr. Rob. Next, we'd like to show you a virtual fish that you can't only see, but also touch. We created this fish using 3D modeling software, and the user needs to wear a special headset to see it. A camera in the headset tracks specially created optical markers made up of unique black and white patterns. The software recognizes a marker and figures out how far it is, and therefore how far away the fish should be. So, the system can generate graphics at the correct position, orientation and scale so that the user can see it. As the headset moves, the system makes calculations in real time to adjust the image. So by moving their head, the user can get a 3D view of all sides of the fish. Now it's time to add another sense. For that purpose, we use this special device, which looks a bit like a robot arm. It's called a haptic device, which means it can provide feedback as pressure. For example, when the user moves the device to touch the fish, the device pushes back so that it can't move any further and it feels like the fish really exists. In the future, this type of technology will be useful for designing and testing virtual prototypes of about any object that you can think of. So there you have it. No magic, just science in this lab. I'm going to keep you guessing how I'm going to do my next trick.